let's start by going through the mechanisms a little bit. And obviously the main mechanism that you've seen is the electrophilic addition mechanism. There will be mechanism problems on the test. The naming, we haven't done as much naming as they had a year ago, because I've covered how to name alcohols and ketones and things like that. This is something I mentioned on Friday, I think, anyway. So it's going to be less on naming and more on, that leaves more room for things like mechanisms and synthesis. So, the exam last year, they'd only really had electrophilic addition and a little bit on free radicals. They hadn't had all the stuff you've had. And they hadn't got onto the redox reaction side. So bear that in mind when you're doing practice exams and things, that yours will include some of those later things that don't form that test. So the electrophilic addition, though, is a simple one would be something like that's your basic electrophilic addition reaction. And a standard question I like to ask is, how can you explain Markovnikov's rule using this? And the answer is because if you added the H here, you would get a primary carbocation, which would lead to that, and you should remember that tertiary is the most stable carbocation, second, then secondary. And also resonance stabilizes these carbocations. So if you can do resonance, that's even better. Okay, are there any questions on that? The thing we want to look at is the ones with cyclic intermediates. So this is chapter 11. This is simple. These are all XI in the notes, but in the book they're separated into two chapters. So a typical example like this, and this is then attacked. If it's in water, and then this just does an acid-base reaction to become neutral. There's a second step usually done to remove the mercury off here. So this is racemic. that. I'd like to mention what other related things there are in this case. In the case of the simple electrophilic addition, we have addition of HCl, HBr, and sometimes HI, but I wouldn't normally give that because it can do side reactions. And addition of H3O plus, which is H2SO4 and H2O, or HOTF. Actually, these are all really the same reaction here. They're all just ones here. H2O plus, but done in different ways. In this case, they often will add sulfuric acid first, which forms an intermediate, and that then is hydrolyzed by this. But it amounts to the same overall process. So if I ask you to give a mechanism for addition of H3O plus or HBr, they're all going to be the same mechanism. With the cyclic intermediates, carbenes, with carbenes there is no leaving group. You notice with the mercury we have to lose an acetate. And in fact with Br2, Cl2, and all of those related reactions, those all have to have Br minus or Cl minus as a leaving group. But with the carbenes, can you see that at the back, the word carbenes? I realize this is. And then the epoxidation reaction. Those are all examples of the cyclic intermediate. So I could pick any of those. Last year's exam I think had a carbene on it, but who knows what I'll pick this time. I haven't written that properly.